Okay guys, I'm super happy to welcome you to a new tutorial series on this channel, where we will build together this mixed reality game from scratch using the Unity game engine and a MetaQuest headset. Not only this tutorial series will teach you the basics to set up path-through and use the scene model, but this series is designed to break down the most important feature of mixed reality. For example, the Raygun will teach you how to collide with the player environment to stop the ray and display an impact. The ghost and the orbs they are trying to eat will teach you how to spawn an object in the player environment. The ghost movement will teach you how to use nav mesh to navigate in the scene. The flashlight will teach you about some nice stencil effect that you can do, and so much more. But to me, one of the coolest things when making this kind of step-by-step tutorial is that I get also the opportunity to teach you some secrets that are often missing on tutorials. For example, making a shader for the ghost, doing a little bit of 3D modeling, adding sound effects, do some optimization for the game to run smoothly, and of course, publishing the game. So you probably guessed by now, there is a lot to cover in this series. Now, in the episode that you are watching right now, we will learn about the setup for mixed reality with the Meta all-in-one SDK to use path-through and the scene model, and then build a cool Raygun that uses the collider mesh to show an impact and stop the ray. In the next episode, we will create the ghost that will own the room and be able to spawn it behind the wall of the player. So you better subscribe if you don't want to miss it. As always, if you'd like to support my work and get access to exclusive content like the complete source code of this game, go on my Patreon, the link is in the description. But most importantly, this series will not be possible without the support of Cognitive 3D. If you don't know what Cognitive 3D is, I previously covered it on this tutorial that I made a while ago, and you guys seem to already like this tool a lot. So Cognitive 3D is a free tool that allows you to collect data in your game to better understand how it is being played. With Cognitive 3D, you can watch replay of your player, get comprehensive data about their session, know if your game meets your objective with the objective system, and much more. Not only it is a great tool, but they agreed to sponsor this tutorial series, so big shout out to them. So go on and try the tool for yourself by registering for free with the link you will find in the description below. You can even start a free trial of the Pro version. But without further ado, let's get started with the tutorial. Okay, so the first step to make a mixed reality game with Unity is to download the Unity Hub, which you can do so on this webpage that you will find in the description down below. You can then click on download over there, and this should allow you to have here the Unity Hub running. Beautiful. Then, of course, you need to install one version of Unity, which you can do so over there on install and by clicking on install editor. As you can see, these are all of the Unity version that I have in my project. For this tutorial, any version above 2021.3 should work. Now, just note that for Unity 6, there is currently a bug running for mixed reality, so don't do this one or wait for it to be resolved. But anyway, what you really want to make sure when installing a Unity version is to have Android over there that is being written, which you can do by simply clicking over there and then on add module and selecting here the Android build support with both OpenJDK and Android SDK and NDK tools, or directly when you first install it from install editor. If you select one version, you can directly install it from here right away by enabling it over there. Now anyway, now that you have a Unity version that has both Android and Windows, you can create your own Unity project. So let's go to project, click on new project over there. Here you can select a Unity version. I'm going to select 2022.3. For the template, let's select the Universal 3D. Now the Universal 3D means that we are using the Universal Rendering Pipeline or URP, which will allow us to have a more optimized rendering pipeline for our game, which will work well for mixed reality. Now anyway, we can give a project name. I'm going to name mine Ghost Hunter. Beautiful. We can set a location, a Unity organization. Then in my case, I'm going to disable the connect to Unity Cloud, and then we can click on create project and wait for Unity to set up everything for us. And there you go, Unity has finally opened, and now it is time for the annoying part where we will need to download the tools and do the setup for making mixed reality work within Unity. But don't worry, this will be soon over and we will be able to get started on making our mixed reality game. Now anyway, let's remove the README asset because we don't need it. Click on proceed, beautiful. And because we are building for the MetaQuest device, this means that we will need to have as a building platform Android. To do so, we can go to File, Build Settings, and let me resize this window. You should see over there the Android. Currently Windows is selected, but if we select the Android and then click on Switch Platform, this will, as the name suggests, switch the platform correctly to Android, which will allow us to build our application to the Quest headset. Beautiful, now that we are on the correct platform, we need to install the MetaXR all-in-one SDK, which will contain all the tools to create a mixed reality game. To do so, you need to go on the asset store and search for the MetaXR all-in-one SDK, and this should land you to this asset right there. By the way, if you want to save some seconds, you will be able to find the direct link to this asset in the description down below. Now anyway, we can first click on download here. Now in my case, I have previously downloaded, so I just need to click on open in Unity. And if you click on open Unity editor, this should directly open the package manager, as you can see, with the MetaXR all-in-one SDK selected. Now the version that we will use is 68, but any version above this one should work, and if anything changes, make sure to go to the comment section down below where I will write anything that you need to do to fix any issue that you should have. Now anyway, to download the MetaXR all-in-one SDK, we can simply click on install over there and wait just a little bit. Okay, it has been installed and now asking us to restart the editor, so let's say yes. And there you go. If we go at the top and that we go to in project, we can see that the MetaXR all-in-one SDK has been correctly installed with all of its core components. This is awesome. So now that is the point where we need to do some settings on the project. It used to be a very annoying task to do, but thanks to a new feature from the Meta SDK called the Project Setup tool, we will be able to do so in a few seconds. But first, let's close here the package manager, go to Edit, Project Settings, and if we go to XR Plugin Management, let's click on Install XR Plugin Management. There we go. Now by downloading the XR Plugin Management, we are telling Unity that we are making a VR or XR game. And here on the Android panel, as you can see, this is where we can set the plugin providers. In our case, we are using the MetaQuest, so let's enable here Oculus, which is, as you know, the old name from the MetaQuest. There you go. So this will allow us to have VR working on Android, but let's go to desktop now and do the same. And now this is where things get interesting, because if we go to MetaXR over there, as you can see, we have the project setup tool opening. And this is what I was just talking you about, which is an awesome tool to make sure that every setup is done correctly inside Unity to make mixed reality works. Now, as you can see, we have some issue currently for both desktop and Android, but we can fix them quite easily by clicking here on the Fix All. Then we can click on Apply All. And there you go. As you can see, everything seems to be good now. We have no more issue on Android, and we can even see that XR is now ready for Android over there. That's awesome. Now what's left is to go to PC, and now we can do the same. We have just one issue currently, so let's click on Fix. And there you go. Everything seems to be good now. And as I was telling you, this is really awesome. You can have a look at all of the little settings that this tool has changed. And that will make sure that mixed reality is running properly within Unity. Now we can close these windows, and the boring part of this tutorial is finally over, because we can now directly build our mixed reality game. So there are multiple ways that we can get started to build our mixed reality game, but because this is a beginner-friendly tutorial, I want to share with you another awesome tool by the MetaXR all-in-one SDK, which is the building blocks. If we go to Meta over there, then on Tools, and then on Building Blocks, this is what you should see, a new window that contains a lot of things. So basically what building blocks are, these are a quick way to add some feature inside your Unity project by simply dragging one of these blocks directly in the hierarchy. For example, here we have the camera rig, which is the most basic component of them all, and that will allow us to have a camera rig for our player inside our game, and that will allow us also to track the position of the controller. So let's simply select it and drag it over there on the hierarchy. And as you can see, this has created a new game object that contains an OVR manager. As you can see, this component is super long and contains some settings for our game. Now, if we go down below over there, we can see that it also contains a camera on the center eye and shore. and that we have the left hand and the right hand ensured that will follow our controllers. Now anyway, because we have created a camera rig that contains a camera, we can select the default camera that was sitting on the scene before and press on the delete key to remove it. We can also do so with the global volume, which adds some post-processing that we don't want, so let's press on delete. And there you go, now it has been removed. But then, now that we have a camera rig, because we are making a mixed reality game, we also want to have path-through working, so let's simply select these building blocks and drag it as well on the hierarchy. And as you can see, this will add a VR path-through layer component to show the path-through, but it will also go on the camera rig and change some settings, like this one. As you can see, this has enabled the path-through now on the OVR manager. So basically, building blocks are a quick way to make sure that everything is running correctly. But of course, if you are a more advanced developer, don't worry, we'll do so much more than using building blocks on this tutorial series, you will see. Now on the quick notes, you can see that we have a little icon showing over there with a little red dot. So this icon is actually telling us that there are some issue within our project settings. So if we click on it, we can see that there is one issue from the project setup tool. So if we click over there, as you can see, this opened the project setup tool from before. But now, because we have made a mixed reality application with path-through, we can see that there are some new issues that we want to fix. And you already know how to fix them. We simply need to click on fix all over there, then on apply all over there. We can do so as well for desktop. There you go, make sure that everything is working as well for desktop, but don't worry about the last issue. We don't need to fix it right now, so let's close this window. And now at this state, we have a mixed reality application working. But of course, the big question is, how can we know? Well, in other words, how can we test our game? And this is what I'm going to share with you now. Okay, so there are basically two ways of testing our game. The first one is to build it and export it directly to the Quest headset. To do so, the first step is to set your Quest to developer mode, which you can do from the MetaQuest mobile application. I will leave in the description a step-by-step tutorial to do so. Then you can plug your MetaQuest headset with a USB-C cable to your computer. And from here, it is very simple. You need to go to File, Build Settings. You should have this window showing with the Android platform selected. And if you've authorized the connection of the headset through the computer, you should see here over there on the list of the run device, which means that we will be able to build the game and export it directly to this device at the end. So let's try this out. Let's simply click on build and run, give a name to the build like test, and click on save. Now we just have to wait a little bit. And there you go. After waiting a little bit, the build has been successful. If we click over there, this should open the console window. And as you can see, after waiting a little bit less than 10 minutes, the build has been completed with a result of succeeded. And now if you put on your VR headset, this is what you should see. As you can see, now we are inside the application that we just made and path-through is working. I can see the computer in front of me. Now, by the way, if you have some issue when building the application, you can click on player setting over there, then on other settings. And if we go here on identification for the package name, it is better to replace this by something like com.yourcompany-name. So let's do Valem and then dot the product name, which is Ghost Hunter. Beautiful. Because otherwise, if two package names are the same for different projects, it doesn't allow you to build. So anyway, we can close these windows. And of course, now that you've seen this first method, as you can see, this is super slow to test. Of course, this means that if you are making some change on your application, you will need to always build your application to test these changes. But what if I told you that there was a way to test directly our mixed reality application within Unity? So for this second method, what you need to do is actually to have the MetaQuest link running. This is an application that you will be able to download, link in the description again. And now with this application, if you connect your Quest headset to your PC with a USB-C cable, you should see it over there like mine. And from here, what you need to do is go to MetaQuest link and then click on launch like this. And after waiting a little bit, you should see this white background, which will tell you that everything is working and that now you are ready to test your mixed reality application directly within your computer. But just before to do so, there are some settings that you need to make sure you have. if we go to settings over there, then on general, make sure that unknown source is enabled. And then if you go to beta, make sure that you have both path-through over MetaQuest link enabled as well as spatial data over MetaQuest link. This will make sure that, well, as the name suggests, both path-through and the spatial data will work this way. Now we can minimize this window and then let's click on play to find out if it is working. And there you go. As you can see, it is working. If I move my head, you can see that the camera is as well moving. I can see my real surrounding. I can even move my hands and everything seems to work. But in your case, all that you see here is a black screen. But I can guarantee you that in the VR headset it is working. It is that for some reason Meta doesn't allow the path-through to show within the game window over there. But inside the headset it is working. And so it is using this second method that you should be able to directly make some change and test them directly inside Unity without having to rebuild every time. Okay, so now that we know how to test your mixed reality application, let's get started on making the awesome Raygun that you saw in the introduction. Okay, so for our Raygun, we of course need an awesome 3D model, and as you can see, I just found this one on Sketchfab, which looks really cool. There it is on Sketchfab. I will leave in the description this link if you want to download it as well. You simply need to click here on download 3D model and then download the FBX version to drag it here in this project. Now, of course, we want this Raygun to follow the one of the hand, so I'm going to simply drag it as a child of the right hand ensure. So here it is, we can see it over there. We can rename it Raygun like this. But if I click on play, you can see that the Raygun is following the right hand correctly, but it's not facing the good direction. So the reason is that if we leave play mode, we can see that the blue axis over there doesn't point to the same direction as the gun, and this blue axis represents the forward axis of the controller. So what we can do is simply rotate the Raygun 90 degrees on the y-axis. And now if we compare it to the parent, we can see that the forward axis of the parent, which is the forward axis of the controllers, is pointing at the good direction. Also, we can see that the starting position of the Raygun is over there, which is the position of the wrist. So what I like to do is select the Raygun and just increase a little bit its position, like so. So that if I select the right hand ensure, it is placed approximately over there near the handle. But of course, what we want with this Raygun is be able to shoot laser with it. So to do so, I'm going to select the Raygun, click on add component, and add a new component called Raygun. There it goes. So on this script, what we need is a reference to a row button by doing public OVR input dot row button that we can call shooting button. There you go. This way, if in the update function, which is called every frame of the game, if we do if OVR input dot get down and that we use our shooting button, then this way we will be able to listen to the button press of the player to trigger anything that we want. So in our case, I'm going to create a public void function called shoot. Beautiful. And I'm going to simply call this shoot function over there. Now, just for testing right now, what we can do is simply write debug.log pew pew just to see if this button is working. Now let's save with Ctrl S, go back to Unity. There you go, we can see our script over there on the Raygun and we can choose a shooting button. Now in my case, I'm going to select the right index trigger. We can save, and now if we click on play, there you go. If I press on the trigger button, as you can see, the pew pew is working, which means that we are able to listen to the trigger button. But of course, more than writing something in the debug console, what we want is to show a laser. So what we need to do is instantiate a line when we shoot instead of writing some text. So for this, let's right click in the hierarchy, go to create empty, and I'm going to call this one red line. Beautiful. We can click on add component and add a line renderer. Now, as you can see, the line is pink right now because it doesn't have a material. So we can go to material over there, click on the right and search for line. Beautiful. You should see here this default line material showing, which will turn everything to white. And we can actually change the color over there by clicking here. You can either select one of the gradient over there, but in my case, I'm simply going to set the start color to red and the end color as well to red. If you'd like, you can also select the first element at the top and change the alpha value to maybe 200 and do the same at the end with a value like 200 or more or less, depending on what you want the end to look like. Now anyway, we can close the gradient editor. But as you can see, the size is a bit too big. So what we can do is actually select the white here and drag it down like this till it seems a bit nicer, like this. And there you go, we have now created our beautiful red line that we can instantiate when we shoot. Now, by the way, if we go to position, we can also change the start and end position of this line, and this is what we will be able to do so using our Raygun script. But for now, let's simply select our red line and drag it in the project folder. This way, as you can see, this will save this game object in our project, and this means that we will be able to instantiate it. Now we can select the one that we add on the hierarchy and press on delete to remove it because we don't need it. And now let's go back to the Raygun script to be able to instantiate this line. Okay, so what we need is a public reference to the line prefab that we can call line prefab. And I will also need two new parameters. The first one is a public transform called shooting point, which will be the start of the line. And then we can use the direction of the shooting point, but what we want is actually a max line distance value that we can set initially to maybe 5 and that we can use to set the line length. Now anyway, in the shooting function, what we can do is instantiate the line by doing line renderer line equals instantiate line prefab. Beautiful. Oh, and by the way, here I'm making a mistake because I'm actually getting the line as a line renderer, but at the top I set the line prefab to be a game object, and this is wrong. We should write line renderer over there as well, and this way, as you can see, this is properly casted. Now anyway, we can set the line position count to be equals to 2, which means that there will only be 2 points on our line. And we can set the first position with set position 0 and the position to be the shooting point dot position. Beautiful. Now for the endpoint, let's simply do vector3 endpoint equals shooting point dot position plus shooting point dot forward multiplied by the max line distance. Now if you don't know what I'm doing over there with this, if this is our Raygun and that this is the shooting point over there, if we want to get the endpoint position, we can actually get this position by adding to this position this vector, which is computed by simply multiplying the shooting point dot forward, so the forward axis over there, by the max line distance. And this is how we can get here this endpoint. Anyway, now that we've computed the endpoint, we can do line.set position 1 endpoint. And there you go. Now, after we've instantiated this line, a good thing would be to actually destroy it after a certain amount of time. So at the top, I'm going to add a new public float variable called line show timer and set it to maybe 0.3. This way, what we can do is write destroy line.gameObject line show timer, and this will actually destroy the line.gameObject after waiting here this time. And there you go, guys. I think that we are already ready. We are now instantiating a line, setting its position. It is now time to save and go back to Unity. There you go. As you can see, we can see all of the new parameters that we've just created. For the line prefab, we can simply drag the red line over there. Now for the shooting point, this is the start position of the line. So what we can do is right click on the Raygun, create an empty that we can call shooting point. And what we can actually do is move this empty game object at the very tip of the Raygun like this. But remember that we are also using the forward axis of the shooting points, which is here this blue axis. So make sure here to set the rotation to -90. This way, as you can see, the blue axis will be correctly set to point in the direction of the gun for the shooting point. Now let's go back to the Raygun and drag this shooting point over there. For the max line distance, we can keep it to 5, and for the line show timer, we can keep it to 0.3. And now everything is ready. We can click on play to find out if we are now able to shoot some laser from our Raygun. And there you go, as you can see, it works. I can shoot with the ray gun, but of course right now, what does not work is that the ray is not stopped by anything. It would be really nice if the ray would stop where it meets our wall, ceiling, floor and furnitures, and this is what's exactly possible with the scene model by Meta. So if you don't know what the scene model is, this is a new functionalities on the Meta Quest for mixed reality that allow you to scan your room to create some data over the player's environment. And this data, we can actually access it on our game. So you guessed it, this is what we'll use to know if our ray is colliding with something. So the quickest way to set up the scene model in Unity is from the building blocks. If we go at the top to building blocks, here they are again. We can actually click on the scene right here at the top and you should see the effect mesh building blocks. If we drag these building blocks in the hierarchy, as you can see, this now creates two things. First, the MR utility kit and then the effect mesh. So the MR utility kit is what will actually get the scene model data. As you can see, it has a world lock that prevents the player to move the scene model when it is recentering. And if we have a look down below, you can see that the MR UK is set to device with prefab fallback, which means that if it does not get any data from the device, it will launch a default prefab among this list, which is also super useful to quickly debug multiple rooms. But what can we do with the scene model? This is what the effect mesh is for. As you can see, the effect mesh will spawn on start and will create for each scene model element a mesh and then assign it this material right here. By the way, if we go down below, you can see that there is also settings to add collider, which we will use in a minute for our ray gun. There is a setting to hide the mesh, but also for the labels. If we click on the label parameter, this is where you can say for which scene model label you want to add a mesh. Right now it is set to everything, so make sure that the global mesh down here is disabled, because the global mesh is basically the complete detailed scan of the room, which we don't want. And there you go. Now that everything is ready, let's find out how the effect mesh looks like by clicking on play. And there you go. This is what you should see. Not exactly this, of course, because this is the scene model from my office. But as you can see, we have a bluish bounding box for all of our furnitures and even for the wall, ceiling and floor. This is cool. And as you can see, if we go under here, this game object, we can have a look at all of the different furniture that was able to be gathered from the scene model by Meta and that now we can use inside our mixed reality game. We have the wall, the ceiling, the floor, but also the desk here, which is super nice. But in my case, I actually don't want any visual or material on the model. I just want to have the colliders to be able to stop the line from the ray gun. So let's leave play mode. And what we can do on the effect mesh is here, we can hide the mesh by clicking over there and we can enable the collider. This way, if I click on play, there you go, we cannot see anything right now. But if we select our room, we can see that a collider has been created for all of its elements. But now that we have collider, we will be able to use this information to stop our line from the ray. So let's leave play mode. Let's save and go back to the ray gun to find out how we can do this. Okay, so to be able to find out if something is in front of the ray when we shoot, we will actually use a ray cast. So let's go at the top and after we write the debug.log that we actually don't need, so let me remove this. What we need to do is create a new ray with ray equals new ray. We can give as a start position the shooting point.position. As a direction, we can use the shooting point.forward. And then we can find out if there is a collider that meets the ray by doing bool has hit equals physics.raycast with our ray. For the output, we can write raycast hits, and then our max line distance. This will be the maximum distance of the ray. And the last setting that we need is a layer mask. So if we go at the top, we can write public layer mask and call this one layer mask simply. We can write it at the end like so. And there you go. Now simply using this line of code, we'll be able to know if we have hit something or not. So in our case, if we have hit something, this is where we can stop the ray. And if we have not hit something, this is where we can do the thing that we did before. which is simply give the endpoint this default value. So actually, let me go at the top and write vector3 endpoint, and we can actually initialize it to vector3.0, and we can simply cut and paste this line of code and remove the vector3 in front, and there you go. This means that when we have not hit something, we set the endpoint to the default value, but if we have hit something, what we can do is simply set the endpoint to be hit.point, which is the position where the ray has found a collider. And there you go, it is as simple as this. We are actually doing nothing more than before, but just using some physics to find out if there is a collider from our real world, and if there is a collider that meets our ray, then we set the endpoint to be the hit position. There it is, so now let's save the script and go back to Unity. Okay, so there is not a lot to set up inside the Raygun script. Just make sure here that the layer mask is set to default. This means that we will be able to find all of the colliders that are on this layer. And now one thing is missing, and it is to find out if this is working by clicking on play. And there it is, look at how cool this is. Thanks to the scene model, we are now able to use some colliders on the wall, on the ceiling, but also on the furnitures that we are using to stop the ray. But I think that we can still improve this awesome Raygun in two ways. First, we will add a sound to be played when we shoot, and then I also want to add a certain impact on the wall to also show you how we can get the normal information of the object that we collide with. Okay, so for the sound, I'm going to use this awesome free sound that I found on this website and that you will be able to find in the description down below. As you can see, it is kind of cool. Now anyway, we can download the sound and directly import it inside our project like this. And if we want the sound to be played when we shoot, we can then go on the Raygun and add an audio source. Beautiful. We can remove the play on awake and set the spatial blend to 3D. Now we can go back to the Raygun, and I'm going to add at the end a public audio source for the reference to the audio sounds that we've added, and then a public audio clip for the shooting audio clip that we've downloaded. And now when we shoot, what we can do is simply do source.play one shot shooting audio clip. Beautiful. We can save, go back to Unity, and we can drag the audio source for the source and the audio that we've downloaded for the audio clip. Beautiful. And now let's just click on play to find out if the sound works. And there it is. As you can see, you should be able to hear an awesome sound effect when we shoot. This is super cool. And as you can see, we were able to make this in just a few seconds. But now for the second improvement, which is adding an impact on the ray, what I'm going to do is right click, go to 3D object and go to quad. Now, as you can see, this will create a 2D quad. And this is what I'm going to use to create an impact effect. We want to change the material on this quad. So let's right click, go to create, then on material and call it ray impact. Beautiful. At the top, we can change the shader to universal render pipeline unlit. We can set the surface type to transparent and the blending mode to additive. Beautiful. Now for a texture, what I'm going to do is click here and I'm going to search for particles and use here this default particle texture. Beautiful. We can now drag the ray impact material to the quad, and this is what it should look like. As you can see, it works pretty well, but in my case, I think it will be even better if I change the color from white to red. And here it is looking nice. Now, if you want, you can change the size of the impact to anything that you want, but I think a value of 111 will be good enough. So let's simply rename this to ray impact and drag this game object in the project folder for turning it into a prefab. Now we can select the one on the hierarchy and remove it. And then let's go back to our Raygun script to be able to instantiate this impact when we shoot. There we go. So at the top, in the same way that we've instantiated the line prefab renderer, let's simply add a public game object called ray impact prefab. Beautiful. That we'll be able to instantiate as well. So what we can actually do is instantiate this one with game object ray impact equals instantiate ray impact prefab. then we can directly set its position to be it.point. But this is where things get interesting, because now what we want is to actually set the rotation of the impact to be the same rotation as the surface that we are hitting. So for example, let's say that this is our surface and that this is our ray over there. Where the ray is meeting the surface, what of course we want to do is orientate the impact in this direction, okay? So to do so, what we need is to actually get the normal and create a rotation with the normal that we just hit. So for this, let's write quaternion ray impact rotation equals quaternion dot look rotation minus it dot normal. There you go. So here with the it.normal, we are getting the normal value of the position that we hit. So in other words, we are getting this value right there. And we can actually create a rotation from it by calling the quaternion.look rotation. And here I'm just adding a minus in front because if we go to our ray impact over there, so let's double click on it, we can see that the forward axis is actually on the opposite side of the showing face. So that's why I need to set it to the opposite direction of the normal that we hit. Now let's go back to the scene by clicking here. Let's go back to Visual Studio and let's simply add the ray impact rotation at the end right here. Beautiful. And now that we've instantiated a ray impact, we can actually destroy it after, let's say, 1 second. Beautiful. And now everything should work. With this, you have seen how we can actually spawn an object to the hit position, but also change its orientation from the normal that we hit. So let's go back to Unity. And for the Raygun, let's simply drag the ray impact prefab over there. And now everything should be ready. One thing still missing, and it is to test our game. And there you go, guys, look at what we just made! The coolest ray gun ever! Now, as you can see, the sound effect and the ray impact add so much more realism, it is so cool! But of course, this is only the beginning. Next week, I will show you how we can add ghosts to our mixed reality game that will be spawned behind the wall of the player, and that we will be able to show that. I hope that you enjoyed watching this tutorial, and if you did, make sure to subscribe to not miss the next one. A big shout out to the new Patreon, which are on the screen right now. If like them you want to get access to the source code of this game and other exclusive content, join us, link in the description. And I could of course not end this video without giving a big thanks also to Cognitive 3D, the sponsor of this series. Thank you for watching and see you very soon. Bye bye!